In this lesson, we're going to learn about modeling using linear functions. This is the third in a multi-part series on this topic. In this lesson, we're going to focus on how to write a model given an initial amount and a point. Modeling, simply put, is writing an equation to represent a scenario. When we write equations, we can write them using slope-intercept form or point-slope form. The form that you will use will depend on the type of information that you're given in the problem. In this lesson, we are going to look at problems that are incredibly flexible. You'll be given a starting amount and a point, but you will need to find the rate of change. Let's take a look at some examples. In our first exercise, Brinley was given a box of assorted chocolates for her birthday. Each night, she treated herself to some chocolates. Originally, there were 36 chocolates in the box. After 4 nights, there were 16 chocolates remaining in the box. Write an equation for C in terms of T representing the number of chocolates remaining in the box T days after Brinley's birthday. This scenario assumes that Brinley is eating the same number of chocolates each night. We begin by reading the problem carefully and identifying the scenario. What's going on here? Well, the number of chocolates left in the box is decreasing. She started with a certain amount, and then each night she ate some, which means our rate of change is a negative number. Originally, there were 36 chocolates in the box. This is our original or starting amount. 36 represents the y-intercept. We are also told some other information in the problem. After 4 nights, there were 16 chocolates remaining. This allows us to create a point. 4 nights, 16 chocolates left. That's the point 4, 16. In order to write an equation, whether we use slope-intercept form or point-slope form, we have to have a rate of change, a rate of increase or a rate of decrease. Regrettably, they don't give us this information in the problem. We're going to need to figure it out. We can use the information given in order to figure out the rate of change. The original amount, the y-intercept, was 36. This can also be written as the point 0, 36. And we have the point 4, 16. If we label these points x1, y1 and x2, y2, we can use our slope formula to calculate the rate of change. The rate of change is -5. That means Brinley was eating 5 chocolates each night. We now have a rate, and we're now ready to write our equation. At this point, we can choose the form that we like the most. We have slope, we have an original amount, which is the y-intercept, which means we could use slope-intercept. We also have a point, which means we could use point-slope. At this point, it's entirely up to you. To me, it seems the simplest to use the slope-intercept form. Y equals mx plus b. Y equals m is -5, times x, plus b, the y-intercept is 36. This is an equation that represents the number of chocolates left after x days. We do need to make sure that we use the variables given in the problem. The problem says write an equation for C in terms of T. This means we're going to have C equals stuff with T. So we can rewrite our equation as C equals -5T plus 36. This is an equation that models the number of chocolates left in the box after T days. The next exercise is for you to try. Bella is signing up for a membership to Club Math with a one-time fee to join and then a monthly fee. The one-time fee to join the club is $100, and the total cost of membership, including the joining fee, would be $300 for 5 months. Write an equation for C in terms of T, representing the total cost of the club membership over T months. Can you write the scenario, identify the information in the problem, and then write an equation? Please pause the video here and come back when you're ready to compare answers. Let's see how you did. We begin by identifying the scenario. The total amount that Bella is spending is increasing as she belongs to the club for more months. This means our rate of change will be a positive number because the amount she is spending will go up over time. In the problem, I noticed that the one-time fee to join the club is $100. This is the initial or the fixed amount, and this is called the y-intercept. I also notice that the fee for 5 months would be $300. This allows us to write a point. 5 months costs $300, so we have the point 5, 300. Now, no matter what form we want to write our line in, we have to have a rate of increase or decrease. That information is not given to me in this problem, so I'm going to have to calculate it. I have the point 5, 300, and I can use my y-intercept to have the point 0, 100. I label my points x1, y1, x2, y2, and then I use my slope formula to calculate the rate of increase. The slope is 40. This means that the fee to join the club is $40 per month. We now have a rate of increase called the slope. We also have a point and a y-intercept. It's up to you at this point whether you use the slope-intercept or the point-slope form. I personally like to use the slope-intercept because I have the slope and the y-intercept given to me. Y equals mx plus b is y equals 40x plus 100. This is the equation that models the cost of belonging to the club for X months. As always, we have to be sure to use the variables given in the problem. The problem says write an equation for C in terms of T. This means our equation will be C equals things with T. So y equals 40x plus 100 will be C equals 40t plus 100. And this is the equation that models the cost of membership to Club Math for T months. So this is how we can write a linear model when given an initial amount and a point. Of course, there are other things that could be given to you in a problem, so you'll want to be sure to check out the other parts in this video series to learn more. Until then, this is everything you need to know to get started modeling with linear functions. You can learn more about linear functions in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.